So in today's lecture, we are going to discuss inner products or dot products between any two vectors in Rn. So, and then some of the properties of the inner product. So how do we define inner product or dot product of two vectors in xy plane? How do we define it? For example, we'll define it later on. Let us start with the xy plane. If we have an xy plane and two vectors, maybe x vector and y vector belonging to R2, then how do we define its dot product? X dot y is nothing but basically x1, x2 if x vector has two components x1, x2 and y vector has two components y1, y2. Then the dot product is nothing but you just multiply the corresponding components of these vectors. It is x1, y1 plus x2, y2. Okay. So this is the dot product of two vectors. Now, if we generalize this concept in Rn and we assume that we have two vectors u and v, they belongs to Rn, then their dot product is basically defined either in this way, u dot v, or we define inner product, we call it again, this dot product as the inner product, and we define it with the brackets less than, greater than, and u comma v. So these are the vectors. The inner product is basically a more general term for the dot product used in Euclidean spaces. So how do we define inner product? It is basically the product of the components of respective vectors u and v n. This is how we define the dot product between two vectors in R. Now, some of the properties of the inner product is we will discuss them. The first property is commutative property. That if we have two vectors u and v belongs to Rn, then their inner product is what it is commutative. Okay. Or in the dot product notation, you can also write that the dot product is always commutative. You can use this notation as well, but I advise you to use this notation here in this course and call it inner product. This is a more general term which we can use for the inner product of functions and polynomials and many other things. Okay, we'll define them later on. So the dot product
question है.
जी.
सर ये ब्रैकेट्स क्या रिप्रेजेंट करें और कोई यानी कि एक ही तरह के होते हैं कोई और भी हम यूज करते हैं?
So basically some different notation than the dot product. In your earlier classes, you define dot product in this way, but here now you will define it in a more general way by using less than, greater than brackets. Okay. So this is what? This is nothing but this u dot v. Just the notation has been changed.
Okay.
In some books, people use, but you can say that in purely mathematics books, they use this notation of dot product and call it inner product. But this is the same thing as we say a dot product in intermediate or A-level classes.
Okay, sir.
It's the same thing. Now, another property of the inner product is distributivity property. It is, if we define it in the form of a dot product, then we need three vectors, w dot u plus v. Okay, this is a small bracket. Now, this is equal to w dot u plus w dot v. It's basically, you are taking the dot product of w with the sum of u and v. So if we open this bracket, we can write the dot product with u and dot product with v. This is called distributivity property. But if we try to write this thing in the form of, by using this notation of inner product, then how can we write it? W comma u plus v with less than greater than brackets. So if we open it, we can write it w u inner product plus w v inner product. Okay, all these are vectors. So this is how we write the distributivity property for the inner product.
Sir, इसमें closure property है?
We'll discuss it. Dot product. Again, if you have any Euclidean vector space, if you change its definition, but vector spaces we define normally the first 5 properties we define the addition of 2 vectors, and then the scalar multiplication. We cannot use dot product for the usual vector spaces. Because either you need a scalar multiple or the sum of 2 vectors. Okay. So sum of 2 vectors is something different, and the dot product or inner product of 2 vectors is something different. Now another property, I hope you get it. If we have any scalar k belongs to R and any vector u belongs to Rn, then scalar multiple of u and v, so not u and v, and we have u and v, 2 vectors in Rn, then k times u inner product v is equal to k times u v inner product, or this is again still equal to u times k v inner product. All these things are same. Just like in the dot product, you can write k times u dot v. This is equal to k times u dot v, and this is equal to again u dot k times v. All these things are equal. Means you can multiply a constant after taking the dot product of 2 vectors, or you can multiply this k with any vector first and then take its dot product with some other vector. These 2 things are same. And similarly, we can multiply k with v and then we can take the dot product with u. So all these 3 things are same in the dot product or inner product. So this is the second property. Sorry, third property. The next property is that number 4, that the inner product of a vector with itself is always greater than 0 for any u which is not equal to 0 belonging to Rn. Okay. So if it is 0, if the next property, you can say that next property, 5th, the inner product of a vector with itself is 0 only if, or if and only if the vector is itself 0. Otherwise, it is not possible. The inner product or the dot product of a vector with itself is 0. It is only possible if the vector itself is 0. These are certain very basic properties of the inner product which you should know. Yes. The distributivity property, and before discussing that, there is a very important relation between the inner product and the norms. Now, if we choose any vector from Rn and we define its inner product with itself, what it would be according to the definition of inner product. It will be, यहाँ पे आपके पास inner product है uv. So what we do, we multiply the respective components with itself. So if we have u here again, then it would be u1, u1, u2, u2, un, un. So it is what? It is u1 square plus u2 square plus so on plus un square. Now what is this? This is basically norm of U scale. Because norm of any vector, we have already defined it. That what is this? It is the sum of squares of its component, then we take the square root. So what we obtain from here, we can say that norm of any vector is equal to the square root of its inner product with itself. This is very important result, which we will use subsequently very often. So till here, if you have any question, you can ask. This is basically the generalization of the dot product in Rn. There is another important property, but it is basically the generalization of the distributivity property. We can use distributive property in order to prove this property. And that thing is what? If we have four vectors, for example, U, V, W, and Z, they're all belonging to Rn, then we can say that U plus V, comma W plus Z. बल्कि इसको पहले लिखें उसको बाद में. So W plus Z, comma U plus V. Because notes में इस तरह लिखा था. So what we do here, we assume that this is one element W, which is, or you can assume that this is X. Now by using distributive property, what we do here, we take, if we have X here, comma U plus V, then what we do, we take the inner product of X with U and then X with V plus. Okay. So this would be this X U plus X V, okay, by using the distributive property. Now instead of X, what do you have here? You have W plus Z. So you can put here W plus Z. Okay. We know that inner product is commutative, so we can write it in this way: U comma W plus Z plus V comma W plus Z. Now you have two new things here. Now you can again use the distributive property here, because U will be written here with W inner product, and you take the inner product of U with Z. So you can open it by using again the distributive property, and you can write U comma W plus U inner product of U with Z. Plus, again, you apply the distributive property here on this inner product, and we can write V comma W plus V comma Z inner product. So in short, how do you define here the inner product between two terms which are the sum of two vectors? You basically define the inner product of U, so of W with U, W with V, Z with W, and then Z with G. So this is how we can obtain four terms of the inner product here. Again, inner product is commutative, so we can write it in this form: WU plus ZU plus WV plus ZV. So these are the four terms which we can obtain out of this inner product of sum of two terms. I hope you get it. If you have any question, you can ask me.
सर ये तो उसी तरह है जब आप दो ब्रैकेट्स को बेसिकली एक्सपांड करते हैं, कॉन्सेप्ट बेसिक कॉन्सेप्ट वही है.
हाँ, बेसिक कॉन्सेप्ट वही है. ठीक है, जैसे दो ब्रैकेट्स को, but you have to know what is the logic between this thing, behind this thing, Because
Yes, of course.
you assume that this is x and this is u plus v, you apply the distributive property. Okay, you apply the distributive property, and then by opening the into two terms, then again on each term you apply again the distributive property. Okay, so this is the main concept. Because this property we'll use it in proving many other properties of inner product, many other results, many other theorems. So that's why I thought we have to clear this. Now, if you have two vectors, for example, u is 1, 3, 0, minus 5, and v is nothing but 5, minus 7, 8, and 3. So how do you define its inner product? I think it's easy. U comma v, inner product is nothing but what you do. You multiply the first component with first, plus second with second, plus third with third, plus fourth with fourth. Oh, and after solving it, you can you get the inner product of these two terms. Now, again, there is another example. I think this is obvious. You can do it very easily. One other example of how to use the properties of inner product is that, for example, if we have let uv belongs to R, maybe n, and it is given that u dot u is 9, u dot v is -7, and v dot v is 16. Okay, and he's asking to compute 3u minus v dot u minus 3v. So this is what you have to calculate. In fact, it is written in the dot product notation. This is equivalent to saying that you compute 3u minus v, comma u minus 3v. Okay, so you have to apply two properties of the inner product. First, you expand them into 4 inner products, and then you can use the scalar multiple property in order to take this 3 out of those inner products. And then you put the values given u dot u, u dot v, v dot v, and then you can simplify and get the answer. I hope you can do it. If you have any confusion, if you have any question, you can ask. You can do it. I hope.
Sir, I suggest एक दफा आप कर दें, फिर we'll take it from there.
अभी जो मैंने पहले property करवाई है, by using that property, what we can write from here? We can write 3u inner product. पहली term का inner product पहली term के साथ, फिर plus पहली term का inner product दूसरी term के साथ, which is 3u minus 3v. Okay, or you can directly write negative here. Basically, बाद में ही लिखेंगे क्योंकि हमने scalar by लेना तो -3 scalar by लेंगे. And now second term with the first and second term with the second. So plus inner product of v with u, and then plus negative inner product of v with -3 inner product. Yeah. अब आपके पास जो values given है वो ये हैं. Okay. What is this u dot v, and v dot v? Other than this, you should not have any scalar here. So what you do here, you can take the scalar out of this inner product. So you can write 3 inner product of uv, and then plus ये 3 बाहर जाएगा और ये -3 बाहर जाएगा. So it is basically 3 into -3. दो scalar हैं, दोनों से बाहर जाएंगे. So it becomes uv, and then plus vu is what? It is again uv. Okay? So you can write it because it is commutative. Plus यहाँ पे -1 and -3. It is -1, -3 times V, V inner product V. Now, what is left in this? You have to put the values of U dot U. Actually, यहाँ पे V नहीं आ रहा, U आ रहा. So U dot U की value यहाँ put कर देंगे. This whole thing is 9. This whole thing is -7. This whole thing is -7, and this V inner product V is 16. You just have to insert values here. You simplify it. You get the answer. Okay. I hope you can do it.
Yes, sir.
सर ये जो जहाँ पे कंप्यूट के नीचे वाली लाइन है जहाँ पे हमने 3u लिखा है, ये सारे एक्सपेंड किया सर, इसमें -v और u नहीं होना चाहिए, हमने खाली v और u लिखा है.
कहाँ पे? पहली
sir.
टर्म में
Second
3u
last.
और
Second last.
u पहली टर्म. दूसरी टर्म में 3u and then -3v. क्या गया?
जी सर, अगले वाले में -v नहीं होना चाहिए.
3 लिखा हुआ है, वर्ड से लिखा है. लिखा हुआ है कि नहीं?
नहीं सर, हमने अब लिखा है, पहले नहीं लिखा.
पहले आपने देखा नहीं यार वर्ड से. अच्छा चलो ठीक है, माइनस आना तो. थैंक यू वेरी मच. So I hope you can do it. The next thing is a very basic thing, but let me ask you if you know it or not. For example, if someone asks you, okay, from the same setting, u dot u is 9, u dot v is -7, and v dot v is 16. Can you compute u dot v times v? And यहाँ पे v भी given होना चाहिए. U dot v, sorry, u dot v is -7. U dot v is -7. Okay. And v is some vector maybe in 1, -3, and 5. It belongs to R3, and this also belongs to now R3. Can you compute this? What is this now?
So ये u times v plus v times v नहीं होगा?
This one? No. It
ये
is
पूरा
u dot v times v. Now there is
जी,
no
जी.
dot product here. It's a simple multiplication. Now remember that the output of a dot product of two vectors is a scalar. Is it a
Yes, sir.
scalar? Yes. Now you have to multiply a scalar with the vector v. Because your u dot v is what? It is -7, so -7 times v. It is what? -7 times, this is your v1 minus v5. And it is what? It is nothing but -7, 21, and -35. So look it clearly here. Okay, यहाँ पे तो dot product है. ये क्या बन जाएगा? It will become a scalar. Because the output of a dot product is always a scalar. It's a real number. So now you are multiplying a scalar, a real number, with a vector. And this is now scalar multiplication. So keep these things in your mind while doing these scalar inner product of vectors. Okay. There is a difference between dot product and scalar multiplication of a vector with the scalar. If you have any question, you can ask me. These are some of the important points which I wanted to make you clear. So don't mix with the dot product and scalar multiplication. These two things are separate and different. If someone asks you to find u dot v, this is possible. Okay. But if someone asks you to find u into v, this is not possible. Okay, this is possible, this is not possible, because we cannot multiply two vectors with each other. We have to check. Basically now this multiplication could be just like the matrix multiplication. Okay, and otherwise, इसका order क्या है? N cross 1, इसका भी N cross 1. So we cannot multiply two vectors in a simple way. Okay, so that's why we define the dot products and cross products of two vectors. But here in this course, we only discuss the dot product because in linear algebra, we define the dot product. Cross product, I hope you know what is cross product. We have defined something. That's a simple thing. But don't mix these two things. This is dot product and this is nothing. This is not defined. Okay? But in the previous example, we defined U dot V times V. This is possible. Okay? Because the dot output of this dot product is a scalar. Is some scalar, and scalar is multiplying with a vector. This is possible. Okay? I hope you get it. Now, in matrix notation, the dot product or the inner product can also be defined as it is defined as U dot V, and this can be written as U transpose V. This is same as we define the basic definition of a dot product. अब U अगर आपके पास एक वेक्टर है U1, U2, so on, UN, transpose dot V is what? Sorry, not dot, only the multiplication. The V is V1, V2, so on, Vn. Now, if you take the transpose of this thing, it will become a row vector, U1, U2, so on, UN. And you multiply it with V1, V2, so on, Vn. Okay? Now, this is simple, a matrix multiplication. And this is possible. Why it is possible? Because the order of this U vector is 1 cross n, and the order of this vector is n cross 1. Now, the columns in the first matrix are equal to the rows in the second matrix. So this multiplication is possible. When we multiply these two matrices, what do we get here? U1, V1 plus U2, V2 plus so on, plus UN, Vn, which is the same as the basic definition we had defined previously. I hope you get it. If you have any question, you can ask. No questions?
Nope.
Okay, that's great. Now, we have certain important properties which relates inner products and dot products. We'll try to prove those properties because we will use those properties on the theorem.
So you said relate inner products and dot products. Inner product, dot product generalization?
No. That relates inner product with the norms. If I said dot product, I'm sorry. Inner product with the norms. So the first one is Cauchy-Schwarz inequality. Cauchy-Schwarz inequality is what is this? This property says that suppose U and V are n2 vectors in Rn, then U dot V inner product mod. It's a mod value. Because again, when you have a scalar is some one real number, then its mod is what? If the real number is negative, it would become positive. It's absolute value of this real number because it's a real number now, dot product. This dot product of two vectors and its absolute value is always less than or equal to the product of their norms. This is what Cauchy-Schwarz inequality tells us. Okay, and this is basically some kind of relationship between the dot products and their dot product of two vectors and their norms. This is called Cauchy-Schwarz inequality. And how do we prove it? In order to prove it, we need to start with some specific kind of a vector and its dot product with itself. Again, the trivial case में तो ये properties hold करेगी definitely. Equality holds if either of u or v is 0. Okay. अगर दोनों में से कोई एक वेक्टर 0 है तो ये इक्वालिटी होल्ड करेगी. यहाँ पे डॉट प्रोडक्ट 0 वेक्टर के साथ 0 हो जाएगा. अगर किसी एक का वेक्टर 0 है तो उसका नॉर्म 0 होगा तो उसका प्रोडक्ट 0 हो जाएगा. So we'll get 0 as equal to 0. So this property or this inequality holds. Now the question is, when both of these u and v are not 0, then we have to prove it by using some kind of technique. So what we do, we assume that u is not equal to 0, or either of the vectors is not equal to 0. Then let t be a real number. T be a real number. In order to prove it, we assume that u or v, they are not 0. And let t belongs to R because the t is some real number, and we define t u plus v. T times u plus v. इसका नॉर्म ले लें, इसका स्केल, या इसका डॉट, इसका इनर प्रोडक्ट ले लें दोनों, इसी टर्म का inner product ले लें with itself, because the norm scale is what it is, the inner product of tu plus v with itself, tu plus v. And why we are doing this, I'll tell you later after proving it. We started with this thing, t times u plus v, where t is some scalar and u and v are those vectors which we took from Rn.
सर एक बात नहीं समझ आ रही, ये हमने इसका नॉर्म लिया हुआ है तो वो इसके कैसे इक्वल हो सकता है? टी यू प्लस वी, टी यू प्लस वी,
टी यू प्लस वी
Property
का
is
नॉर्म
square root.
तो अभी हमने वो बताया नहीं था कि नॉर्म और इनर प्रोडक्ट क्या रिलेशनशिप है.
अच्छा अच्छा
Norm
जी
of
जी
u
सर,
is what? Norm of u square is what? It is norm of u is what? Square root of inner product of u with v.
यू ठीक ठीक
Okay?
सही.
So now you assume that this is whole u. So then u norm square is what? U
यू
inner product. Okay?
सही.
So we started with this. Why do we started with this? I'll tell you later on. But now you assume that we have this thing. Now, if you use that property, which I told you earlier of distributivity property, you get the two terms here and two terms. What do we get here? T square norm u, so inner product u plus ये अपने इन दोनों को अप्लाई, फिर इसको इसके साथ करेंगे और इसको इसके साथ करेंगे, तो ये क्या आ जाएगा? 2 times t times u v inner product and then plus v का inner product v के साथ. Okay, so this is what we obtain here after taking the inner product of these two. Finally, remember that we have to prove this. We don't have much space, so I have to erase this thing. So next thing is t square norm of u square, because inner product of u with itself is what? It is norm u square, by using that result, plus 2t u v inner product plus norm of, यहाँ पे क्या आ जाएगा? Norm of v whole square. Now, this whole thing is always positive. Why it is so? Because this thing is positive. We started with TU plus V norms here. And this is always greater than 0. So now we are simplifying it. There's no change here. If this thing is greater than 0, because norm is always greater than or equal to 0. You can put here equal to 0 as well. So because the norm is always greater than or equal to 0, so we are simplifying this thing now, which is always greater than or equal to 0. So we put it that this thing is greater than or equal to 0. Okay. Now, if we assume that this is A, it is A t square plus, assume that this is B. We can say that 2bt, and we assume that this is C plus C. Okay. And this whole thing is greater than or equal to 0. Now, what is this? Now, this is a quadratic equation with the positive constant. Here you have positive number, here you have positive number. Okay. Then this whole quadratic expression cannot have non-zero real roots. Why is it so?
Because the values are never equal to 0 of A, B, and C.
Okay, if you have
Less than 0, sorry, less than.
this kind of quadratic polynomial, अगर ये positive है, ये भी positive है, and this whole thing is positive, then this is also positive because every term should be positive. So if you have a polynomial, for example, x squared plus x plus 1, and this whole thing is greater than or equal to 0, then its graph should be what? Should be what? It is always maybe
Parabola.
either it is parabola है, upward parabola होगी, ठीक है? या तो ये 0 में से पास करेगी, या तो इसका 0 रूट होगा, या फिर इसके रियल रूट्स नहीं होंगे, कॉम्प्लेक्स रूट्स हो सकते हैं इसके, ठीक है? It's kind of this, because this whole parabola is always positive or equal to 0. जब ये equal to 0 होगी तो उसका रियल रूट, सॉरी 0 रूट होगा उसका, x equal to 0 उसका रूट होगा. अगर ये हमेशा पॉजिटिव है तो फिर इसके रियल रूट्स नहीं हो सकते, क्या होंगे? हमेशा कॉम्प्लेक्स रूट्स होंगे, ठीक है? And in order to find the roots of this quadratic polynomial or parabola, t किसके इक्वल होगा? t should be you can say that negative 2b plus minus square root of b square minus 4ac divided by 2a. ये आपको फार्मूला ये याद है ना? आप जो
सर एक क्वेश्चन. सर आपने कहा है कि या तो 0 रूट्स होंगे या रूट 0 होगा या कॉम्प्लेक्स होगा जो पॉजिटिव है. पॉजिटिव है तो कॉम्प्लेक्स कैसे है, ये नहीं समझ आई.
देखिए, आपके पास रूट किसी भी फंक्शन का क्या होता है? किसी भी फंक्शन का रूट वो वैल्यू होती है जहां पे वो एक्स एक्सिस को क्रॉस करता है.
राइट सर.
ठीक है, वही रूट होता है ना. तो ये पैराबोला है, क्वाड्रेटिक पॉलिनोमियल है, तो इसका रूट या तो ये 0 को टच करेगा सिर्फ, या ये ऊपर होगा 0 से, क्योंकि ये ऑलवेज पॉजिटिव है, ग्रेटर देन इक्वल टू 0 है इसका ग्राफ जो. तो इसका या तो 0 रूट होगा x इक्वल टू 0, या इसका कॉम्प्लेक्स रूट होंगे, रियल रूट्स नहीं होंगे. क्यों? क्योंकि ये अदर देन 0 ये किसी भी नंबर से पास नहीं करेगा. यहाँ से या तो यहाँ से ऊपर जाएगा, या फिर क्या होगा, यहाँ से ऊपर जाएगा. अदर देन दैट अगर ये ऑलवेज पॉजिटिव, रियल रूट्स नहीं होंगे. इट कैन नॉट बी लाइक दिस, ये इसके रियल रूट्स आ जाएंगे अगर ये इस तरह होगा. दिस क्वाड्रेटिक पॉलिनोमियल.
सही.
ठीक है, आई होप यू गेट इट. सो अगर इसके क्वाड्रेटिक इसके 0 या नेगेटिव रूट्स हैं, सॉरी कॉम्प्लेक्स रूट्स हैं, then we can say that square root of b square minus 4ac is basically क्योंकि यहाँ पे b क्या है, b is 2b है ना, तो 2b आएगा यहाँ पे. अच्छा उस सारे को उसने b कहा हुआ है. It's not like that. सारे को उसने b कह दिया. This whole thing 2 and this thing is को b कह दिया. So it is like b square minus 4ac must be less than or equal to 0. अगर इसके either it has real roots, zero root or the complex root, तो फिर क्या होगा? b square minus 4ac must be less than or equal to 0. This must be true because the discriminant in this case will be less than or equal to 0 if that polynomial have complex roots. So it means अगर आप इसके रूट लें या ना लें, it doesn't matter. तो आप यहाँ से b की वैल्यू अगर पुट करें तो b की वैल्यू क्या आएगी? 4 and u dot v inner product का स्केयर आएगा. हाँ, आप इसको यूज करके तो इसका स्केयर ले लें. -4, what is a? A is nothing but norm of u square, and ac is what? Norm of v square. यहाँ से ये 4 और 4 कैंसिल हो जाएगा, ठीक है? And this is less than or equal to 0. आप इसको दूसरी साइड पे ले जाएं and then take the square root on both sides, you get the required result. So this one becomes u v less than or equal to norm of u into norm of v, which is the Cauchy-Schwarz. Now, if you have any question, you can ask me. Now let's come back to this thing. Why we have started with this thing? Tu plus v whole norm scale. It is very difficult in mathematics to prove some kind of identities or inequalities or equations or results. So you have to think a lot before knowing how to prove it and how to start the proof. It is very difficult. Okay, some theorems cannot people they are, for example, this thing might have someone Cauchy and Schwarz. They might have taken 10 years, 50 years to prove this inequality. It's not easy to think how to prove a certain property or certain inequality or certain result in mathematics. It can take years and centuries maybe to prove a certain result. So you have to remember that in order to prove this Cauchy-Schwarz inequality, you have to start with this thing. Otherwise, we cannot prove this inequality. Okay? I hope you get it. If you have any question, you can ask me.
So that was a philosophical answer to the question. I was hoping for a more empirical answer.
Yeah, because in mathematics, you have to, certain things they have this kind of answer, philosophical kind of answer. Because if you are a very good mathematician, try to prove this result by using some other method. If you are that much kind of intellect, so you have a right not to accept his proof. You can give your proof as well, which is more easy to understand or more valid or more easy than this proof. Okay, in mathematics, बहुत सारे ऐसे थ्योरम हैं जिसको प्रूफ करने में maybe 100 साल लग जाएं, 200 साल लग जाएं. Fermat's एक French mathematician था, he gave this statement. Pythagoras theorem का नाम सुना? Pythagoras theorem क्या है? A square plus B square is equal to C square for any right angle triangle. If this is A, this is B, this is C. So this equality holds. This is the Pythagoras theorem. Fermat say whether this equality holds. If we put n here, Cn for all n greater than 2, whether this equality holds or no. Now, can you prove this? Fermat's is a French mathematician who gave this. This is called Fermat's theorem. 500 साल बाद अभी एक रशियन मैथमेटिशियन ने इसको सॉल्व किया. ठीक है. So it's not easy to.
So ये होल्ड नहीं करेगा ना?
नहीं करेगा.
करना नहीं चाहिए.
लेकिन इसको प्रूफ करना है कि होल्ड नहीं करता. ठीक है. तो इसने ये आइडेंटिटी 500 साल, आई एम नॉट श्योर कि 500 साल, लेकिन मे इट्स अराउंड, ठीक है, इतने ही साल लगे एक अभी रशियन मैथमेटिशियन ने इसको प्रूव किया कि ये होल्ड नहीं करती. दिस इज नॉट ट्रू. ठीक है. तो इट कैन टेक maybe 10 years, 50 years, a couple of centuries to prove a certain statement in mathematics. It is very, very difficult to guess where we have to start in order to prove this result. So that's why it takes a lot of time to prove the mathematical results. Yes.
Just disprove करने के लिए तो don't you only need one counter example?
Yes.
मैं भी यही सोचा था.
Give it to me.
Sir, 4 cube plus 5 cube is not equal to 9 cube, I guess.
But mathematicians, they wanted some rigorous mathematical kind of proof. Okay. They were actually trying to prove it. For some, for all नहीं कर लें आप, for some कह लें आप. यहाँ पे I don't exactly remember this statement. For some n greater than 2, maybe. Now it's completely different. So it was just to give you basically a reasoning that why Cauchy has started with this thing. Okay. I hope
वैसे ये proofs हमारे उसमें included है, यानी कि questions वगैरह में आ सकते हैं.
बेटा these are not इतने कोई rigorous proofs नहीं हैं. You should remember these proofs because these inequalities and properties, they have been used extensively in many other branches of mathematics, sciences. So you should know what is Cauchy-Schwarz inequality and how to prove it. Because then
Right.
you can use it very confidently in some other concepts. I hope you get it.
Yes.
Next concept is angle between two vectors. आप लोगों ने angles तो पढ़े होंगे. अगर आपका दो वेक्टर है तो उसके दरमियान एंगल क्या होगा? Cosine of theta. How do we define it? Or you can say that if you have two vectors u dot v, then it can be its mod, or you can say you don't need to take mod. U dot v, the dot product, another definition of dot product is what? It is, you might have studied it, u mod v mod cosine of theta. इस तरह की definition आप लोगों ने पढ़ी होगी dot product की. This is also a definition of dot product, but this is only valid in R2 and R3. Yes? No? No. It is still valid in Rn as well. अगर इसको जनरलाइज करें और हम कह दें कि ये पहले क्या थे? मॉड थे. अब क्या बन जाएंगे? नॉर्म्स. Okay. So now u dot v, or inner product of u and v, it is basically nothing but this thing, cosine of theta. Where theta is what? Theta is angle between u and v. And remember that theta is always between 0 and pi. Okay. Theta is always between 0 and pi. Why is it so? Because if it is greater than pi, we can take the other direction of the angle. Clockwise, this is basically anti-clockwise direction of the theta. If you have two vectors, for example, this one and maybe this one, okay, this is u and this is v. then this is the angle between these two vectors. This angle should be between, and this is what? This is anti-clockwise angle. It should be between 0 and pi. This is your 0 angle, this is your pi angle. Now if you take the other direction, clockwise direction, then the theta becomes negative theta, but it doesn't change anything because the cos of negative theta is equal to cos of theta. Okay, because cos is an even function. So that is why we take here theta between 0 and pi. Now, the angle cos of theta can be written as the inner product of u, v divided by norm of u into norm of v. This is how we define the angle between two vectors. This is cosine of theta is equal to this. And the theta is basically what? It is cosine inverse of this whole thing. U dot v, unit product divided by u norm and v norm. This is how we can find the angle between two vectors in Euclidean vector spaces, or between the two vectors in Euclidean space. I hope you get it.
सर वैसे इस कोर्स में फिर हम probably वो specific values के साथ काम करेंगे क्योंकि calculators तो allowed नहीं है.
हाँ, क्या कह रहे हो?
इसमें तो हम specific ratios of cos के साथ फिर probably काम करेंगे ना जो याद करनी होंगी क्योंकि इस तरह calculator के बगैर.
You can remember a couple of values of cos theta.
सही.
It's a very simple thing. Nobody is going to ask you any question in the exam, I think. It's a very simple thing. Now, when two vectors are orthogonal, orthogonal means perpendicular. Okay? If you have two vectors, u and v, if they are orthogonal, what they do, they are making, in fact, 90-degree angle with each other. If they are making 90-degree angle, then according to this equality, cos of 90 is what? Cos of 90 is 0. And we have u inner product v divided by u norm and v norm. Okay? If this thing is 0, then this denominator goes there and again make it 0. So what do we obtain? U inner product v is 0, in short. If u is perpendicular to v, this implies, or orthogonal, if u is orthogonal to v, then their dot product or inner product must be 0. Okay? So if two vectors here in Euclidean spaces, they are orthogonal, then their dot product must be 0. So remember this thing. I hope you can do it. A very good example here of the linear systems, maybe linear system with single equation. If we have two vectors, we can easily prove whether they are orthogonal or not. You just have to take, you have to find their inner product. If the inner product is 0, we say that they are orthogonal. Now, there is a very interesting question here. Let u is equal to 1 minus 3 minus 2. U is equal to minus 1. Whatever it is. 1 minus 3 minus 2 minus 7. 1 minus 3 minus 2 minus 7. Find all the vectors which are orthogonal to u. That's how can you find it? Anyone?
So we have to find a dot product that results in 0. तो हम कोई एक v ढूंढेंगे जो उसके साथ u के साथ मल्टीप्लाई होके 0 बनाएगा.
लेट हम कहते हैं कि u तो वेक्टर हमें गिवन है. हम कहते हैं कि v कोई भी वेक्टर है R4 में से, क्योंकि u R4 में से है ना. ठीक है. तो v के जो एक्सप्रेशन होगा वो क्या होगा? It should be v1, v2, v3 and v4. Now if we define the dot product u comma v, then it would be what? It would be v1 negative v2 3v2 negative 2v3 negative 7v4. So this must be equal to 0, okay? Because we are seeking, we are trying to find the orthogonal vector. So this must be equal to 0. Now what is this? This is a single linear equation, which is luckily homogeneous as well. Okay. Now you can solve it and find the values of v2, v3, v4, and v1. How can we find it?
Sir, I'm really sorry, मेरा internet थोड़ा stuck हो गया था. Orthogonal क्या होता है यहाँ पे?
Orthogonal whose dot product is 0.
अच्छा सर. सर हम इसका linear combination बना लेंगे.
How can we solve it? Or either can we solve it or not?
No, क्योंकि आपके पास 4 variable है और एक equation.
So अगर आपके पास ऐसा linear system हो, this is your linear
So free
system.
variables.
Yes, we have to introduce free variables, at least 3. So what we do here, we define v2 is equal to t, v3 is equal to r, and v4 is equal to s. So v1 becomes then, v1 is what? It is nothing but 3t plus 2r plus 7s. So now you can define v1, v2, v3, v1, v2, v3, v4 in terms of these vectors. So v1 is what? It is about 3t plus 2r plus 7s. And v2 is what? It is 3. v3 is what? r. v4 is what? s. Okay. Now you can further separate them and find 3 vectors. You can write it now in further in this way. 3t, t by common ले लें, 3 1 0 0 plus t over here r common ले लें. What do you get here? 2 0 1 0 फिर s common ले लें. What do you get here? 7 0 0 1. Okay. So how many vectors are there which are orthogonal to u? How many vectors are there
3.
which are orthogonal to u? How many?
3.
No.
Sir, infinite होना चाहिए.
Infinite many. Because t, r, and s, they are real numbers. They could be anyone. So infinite many orthogonal vectors to this u vector. Now, can you imagine now कि 2 dimension में आपके पास maximum एक वेक्टर है, अगर उस पे कितने ऑर्थोगोनल वेक्टर्स डिफाइन कर सकते हैं आप 2 dimension में? 2 dimension में अगर आपके पास कोई एक वेक्टर है, फॉर एग्जांपल दिस वन, हाउ मेनी ऑर्थोगोनल वेक्टर्स यू कैन डिफाइन ऑन दिस वेक्टर? ये ऑर्थोगोनल होगा, ये भी होगा, ये भी होगा, ये भी होगा.
तो infinite.
लेकिन they are all
लेकिन in a bound.
They are all parallel. Parallel है ना? In fact, you can define only one orthogonal. You can define at maximum 2 mutually orthogonal vectors. ठीक है? In R cube में आप कितने orthogonal vectors define कर सकते हैं? Mutually orthogonal?
2.
3. R cube में यहाँ 3 vectors define कर सकते हैं ना? R cube में mutually orthogonal की बात.
Right.
Oh,
Mutually
अच्छा.
orthogonal. Right.
एक होएगा तो उसका दूसरा होएगा. अच्छा.
R4 में कितने define कर सकते हैं? Mutually orthogonal.
Infinite.
4.
Infinite.
ठीक है? Infinite. Sir,
क्योंकि fourth dimension हम draw नहीं कर सकते.
draw नहीं कर सकते. We don't know. आप ये देखें ये वाले वेक्टर्स भी आपस में लीनियरली इंडिपेंडेंट हैं या नहीं. ये जो वेक्टर्स जो जनरेट कर रहे हैं इन सारे ऑर्थोगोनल वेक्टर्स को, ये these are all linearly independent vectors. If you look at them, we cannot obtain one vector from the other vector. So we can define infinite many orthogonal vectors to one vector. I hope you get it. If you have any question, you can. There is another inequality which we are going to prove, which is called triangular inequality. After this Cauchy-Schwarz inequality, these are certain. There are other certain properties which are important, and you are going to use these properties very extensively in some other courses, particularly in machine learning, data science. आप देखेंगे कि ये क्या कमाल करती हैं inequalities आप लोगों के लिए machine learning and data science में, if you are going towards that field. And the next is triangular. Let we have two vectors u, b belongs to R, then norm of u plus b is always less than equal to norm of u plus norm of b. Okay? And geometrically, what is this? If you have two vectors, this and this one, this is your u vector, this is your b vector, and this is what its sum is. This one, it is u plus b. Okay? Now, what is their norms? Their norms are basically length of these vectors. So this is length of u, this is length of b, and this is the length of sum of u plus u and b. You can imagine that what is this? This length of sum of two vectors means length of this side, length of one side of a triangle must be less than or equal to the sum of lengths of other two sides. This is what we call triangular inequality. So in order to prove it, you start with the left-hand side. Okay, so you assume you start with the norm of u plus v whole square. Why do we do it? Because we cannot simplify norm, but we can simplify the inner product. So that's why by using that similar inequality, result, we can write this norm of u plus v whole square is equal to what? Inner product of u plus v and comma inner product of u plus v. This is how we can write it. Now, we can simplify this inner product. So that's why we are trying to bring this norm in terms of inner product by using that result. I hope you know. So this is now, it can be written as norm of inner product of u plus 2 times inner product of u_v. You can open it, I hope you can do it. So this is inner product of v. And furthermore, we are going back to norm and u का inner product u के साथ itself क्या होगा? This norm of u square plus 2 inner product u_v plus this is what is the norm of v whole square. Now, this is what? This is norm of u plus v. Now, if you take the absolute value here, it doesn't change anything. You take the absolute value here because this is already positive, it doesn't change anything here. Now, when you take absolute value here, okay, then by using absolute value property, which is a very basic properties, you must have known this property. Absolute value property is what? Absolute of a plus b is less than or equal to absolute of a plus absolute of b. Okay, this thing. Now, if you choose the absolute of this whole thing, it is what? A plus b plus c. So we can apply the generalized property of that absolute value property, and we can write this thing is less than or equal to, this thing is less than or equal to absolute value इसकी, फिर इसकी absolute value, फिर इसकी absolute value, u b. अब u क्योंकि norm है यहाँ पे, तो norm की absolute value तो क्योंकि नॉर्म पॉजिटिव होता है हमेशा और ये स्केयर भी है तो ये पॉजिटिव होगा, तो इसलिए एब्सोल्यूट वैल्यू इसकी यही रहेगी, v की भी वही रहेगी, एब्सोल्यूट वैल्यू इसकी हमने ध्यान दी। Now what is this? This is basically this is nothing but absolute value of u dot v. Okay. And by using Cauchy-Schwarz inequality, what do we can write here? U dot v का जो absolute value होगा वो किसके इक्वल होता है? That's equal to norm of u into norm of v. You know, this is Cauchy-Schwarz inequality. Now this thing, whole thing is further less equal to this. So it becomes now, we can write this thing as u plus v, norm square less or equal to u norm square plus 2 norm v norm plus v norm plus square. What is this now? This is nothing but it is this is less than norm. What u norm plus v norm whole square. यहाँ से square और square cancel हो गए. What do you get? You get the triangular inequalities which we have required, which we were required to prove. So, norm of u plus norm of v is always less equal to norm of u plus norm of v. This is what is the triangular inequality. I hope you get it. If you have any question, you can ask. Do you have any question? You can ask me. The next
सर
thing is
आप ये वाला एक स्टेप सिर्फ फिर से एक्सप्लेन कर दें जिसमें हमने एक्सपैंड किया था u कॉमा v यानी कि u इंटू वी को फिर ये u स्क्वायर प्लस 2 इंटू यू वी प्लस वी स्क्वायर और फिर हमने एब्सोल्यूट वैल्यू जो ली थी ये जो बोर्ड के एंड में जो है।
देखिए शुरू में हमने ये वाला
जी
ये
और
वाला
इससे फिर हम ऊपर कैसे गए?
इससे पहले तो हमने वो प्रॉपर्टी यूज की ना, वो जो हमने डिस्ट्रीब्यूटिव प्रॉपर्टी नहीं प्रूफ की थी।
जी जी
w प्लस
जी वो समझ आ गया था।
वो ठीक है, फिर वो दरमियान में दो सेम टर्म्स आ जाती हैं, उसको हम 2 टाइम्स कर लेते हैं।
जी जी सही है।
b u जो है वो 2 टाइम्स हो जाएगा। अब यहाँ पे क्या है, वी आर यूजिंग एब्सोल्यूट प्रॉपर्टी, एब्सोल्यूट a प्लस b प्लस c की एब्सोल्यूट वैल्यू जो है ना, दिस इज ऑलवेज लेस इक्वल टू एब्सोल्यूट वैल्यू ऑफ a, एब्सोल्यूट वैल्यू ऑफ b, एब्सोल्यूट वैल्यू ऑफ c। This is the property of absolute values.
जी
ठीक है, now we are taking absolute value on both sides of these things. यहाँ पे absolute value ले लें, it doesn't change anything because inside we have a positive number, so absolute will change nothing. ठीक है, अब यहाँ पे absolute लेंगे ना, यहाँ पे इसके whole पे, तो फिर property less than or equal to हो जाएगा यहाँ पे when we use this property. अब पहले इसका एब्सोल्यूट होगा, फिर इसका एब्सोल्यूट होगा, फिर इसका एब्सोल्यूट होगा। ठीक है, जो पहली और आखिरी टर्म है दे आर पॉजिटिव, इस पे एब्सोल्यूट का कोई इफेक्ट नहीं होगा। होगा या नहीं? क्योंकि दे आर ऑलरेडी, क्योंकि एब्सोल्यूट वैल्यू प्रॉपर्टी क्या होती है, -7 का एब्सोल्यूट वैल्यू +7 होता है। ठीक है, तो अब यहाँ पे एब्सोल्यूट वैल्यू ऑफ u इन प्रोडक्ट v है, u इन प्रोडक्ट v का एब्सोल्यूट वैल्यू या डॉट प्रोडक्ट u और v का इसके एब्सोल्यूट वैल्यू क्या होती है, बाय Cauchy-Schwarz inequality दिस इज लेस इक्वल टू norm of u into norm of v। इससे पहले जो हम, ठीक है, अब यहाँ पे 2 एब्सोल्यूट वैल्यू ऑफ u डॉट v की जगह हमने क्या लिख लिया, हमने लिख लिया लेस इक्वल टू 2 norm of u norm of v। अब ये क्या बन रहा है, बेसिकली दिस इज योर a square plus 2ab plus b square, so it is a plus b whole square।
सर वहां पे आपने एक इनइक्वालिटी को सब्स्टिट्यूट किया।
यहाँ पे मैंने इस Cauchy-Schwarz inequality के रिजल्ट को सब्स्टिट्यूट किया।
सर नॉर्मली इक्वालिटीज को करते हैं,
यहाँ पे इनइक्वालिटी फर्दर इनइक्वालिटी हो जाएगी ना यार। देखिए
इसको
if I say you 2 is less than 3 and 3 is less than 4, can I say that 2 is less than 4? Is it true or not?
It's true.
So we can do that. There is no harm in it.
Right.
ठीक है, just to, in order to obtain the desired result, we can do any logical step in mathematics.
It's just something I'm not used to seeing.
देखिए हमने प्रूफ करना है बेसिकली हमारे पास ये रिजल्ट है maybe you can say that let me give you another example. We have to prove that 2 is less than 7. Okay? I start with this 2 and I say that 2 is equal to 1 plus 1. Okay? ये 2 नहीं यहाँ पे 4 कर ले, ये 5 कर ले. We have to prove 5 is less than 7. So 5 is equal to what? 2 plus 3, okay? Which is less than 7. Sorry. And I say that 3 is less than 5. Okay? This I know, this result. Now I can now, if there is equality, I can use this result. 5 is equal to 2, sorry, less than 5 is less than 2 plus अब 3 5 से less है तो 3 की जगह हम यहाँ पे 5 put कर दें, which is 2 plus 5 is 7. So it means 5 is less than 7. हमने proof क्या करना था, ये करना था. So this is the idea of this inequality. In fact, so here we have used Cauchy-Schwarz inequality instead of this 3 is less than 5. So it's a kind of similar kind of concept or reasoning which we have used here in order to prove it. The next thing is Pythagoras Theorem, which is basically a special case of this thing. अब देखिए यहाँ पे हमने जब ये किया ना 2 inner product UV, Pythagoras Theorem में क्या होता है कि ये दोनों वेक्टर्स आपके पास राइट एंगल ट्राइंगल है अगर, तो ये एक वेक्टर आपके पास सॉरी एक वेक्टर आपके पास एक वेक्टर आपके पास u है, एक वेक्टर आपके पास v है. ये क्या होगा, u plus v होगा. पहले हमने जो ट्राइंगल बनाई थी वो क्या थी, any triangle, that could be any triangle. But if the triangle is right angle triangle, then there is a 90-degree angle between the vectors. अगर इन दोनों के दरमियान 90-degree angle होगा तो इनका inner product क्या होगा, 0. अगर इनका डॉट प्रोडक्ट 0 होगा तो आपके पास यहाँ पे जो हमने यहाँ से स्टार्ट किया था, this is basically equal to whole square equal to u square plus v square. वही जैसे हमने ट्राइंगल इक्वालिटी प्रूफ की है उसी तरह ये प्रूफ करें, एक्सेप्ट दैट के u डॉट v जो है आपके पास 0 होगा. I hope you can do it. If you have any question, you can ask. If you don't have any question, then I think.
Sir, I wanted to confirm one thing. Is the multiplicative identity supposed to be unique?
Every identity is supposed to be unique. Additive identity भी unique होती है अगर हो तो. Multiplicative identity
Yes.
भी unique होती है अगर हो तो. ठीक है?
Yes, sir. Thank you.
Any other question? जिसको क्विज या क्विज के मार्क्स नहीं मिले ना मुझे ईमेल करे. I'll see that. क्यों नहीं? If you don't have any question, I'm going to stop this meeting.